I'm Paige Marinchuk, and I'm going to be talking about unit testing in game development and how to write your own unit testing framework. So just a quick introduction about myself. I am a programmer, a writer, and a pixel artist. You can see some of the stuff I've done on the side there. I'm the founder of Assembly Games here in Ottawa, and I'm a software developer at UI in product engineering. I'm also a programmer on Snacko, which is a farming cat venture game. I'm also part of Ottawa Games, and I've been helping with that since the founding of it. I've written a unit testing framework for GameMaker, and I've also written an integration testing framework for React Native at UI. So a quick overview of this presentation is I'm going to go over what a unit test is and its structure, just so that everyone has a clear understanding. Then I'm going to talk about unit testing in game development, what's available, why you would even want to use it. I'm going to show you a couple of examples of using unit testing in Gatela, and then I'm going to go over what you need to know to make your own framework. So, with all that being said, you change one thing, and now everything is broken. And, how many times have you run into that problem where you fix it and other things are broken? It's super annoying. It wastes a lot of time. It stalls development, and it really gives you dread when a release is coming. So, what are our options to stop that from happening, right? And so we could manually test everything all the time, right? Every time you make a change, just go through the whole game. But that's really unsustainable. It's really boring. It's not scalable. The bigger your game gets, the harder that's going to be. And because you're having a person do it, it's quite slow. So then let's manually test stuff before release. And that's fine, but you end up with these huge bug bashes. You reach the end of your milestone, you go to test, you find out 100 things are broken. And like I said, that gives you release dread, right? You are fearful of releases because you know this is going to come. And you end up with the situation of asking yourself, when did this break? How long has it been broken? Is it even supposed to work like this? And so these two options, they really aren't going to solve our problem. So may I present test automation? So manual testing is slow. It takes a lot of time because a person is doing it, and each person tackles testing differently. Some people are more focused on graphical changes. Other people are more focused on, placement of items. Like it's not standardized. But that being said, manual testing is really good for conceptual, emotional, and exploratory testing. It's good for testing, like if your UI is responsive, if you have dialogue in your game and the spell checker says everything is fine, but you have a human go and read it and it makes no sense, they can tell you that. Really good for catching and doing things and breaking things in a way that you wouldn't have expected. So manual testing can test the things that you can't automate. Automated testing, on the other hand, is really fast. It can be done in like milliseconds. And each test will execute the exact same way every time. So it's really reliable. And as your game adds new features, it's easy to add more automated tests than manual testing, just more, right? Like throwing people at the problem. And it's really good at repetitive, boring tasks. The only problem is that like it can't adapt if the UI changes, right? If you have a test that's supposed to click on the menu button moves, test is going to fail. That's not going to happen with manual testing, right? And it will do as it is designed. So 100% automation isn't possible. So in that way, let the computer test the boring parts. So I'm going to quickly go over what unit testing is. And unit testing is just a form of automated testing. It's testing the smallest piece of code that can be isolated. And so that's like functions, classes, methods, and so on. And it uses a framework to structure and execute the tests. And it also uses an assertion library to ensure the results are expected. So you may have heard some common frameworks like Mocha, Jest, Chai, Behat, Cucumber, Gtest, Ctest, JUnit. There's a lot of different unit tests. A lot of languages have usually at least one. So what about game development? What options do we have? And so I picked 4 of the most popular game engines right now. So Unreal and Unity have their own testing frameworks they've developed. Unreal supports unit, screenshot, integration tests, smoke tests, etc. There's a lot of options. Unity seems to only support unit and integration tests. Godot supports DocTest, which is a unit testing framework. And GameMaker has no official supported unit testing framework at all. You have to rely on the marketplace. And in the screenshot, you can see my unit testing framework I wrote for GameMaker. So just quickly to go over the structure of a unit test, because this will become very important when talking about how to make your own framework. The unit test structure is basically a name, a test function, and expecs. There's arranging, which is setting up what you need to run the test, acting, which is executing what you're testing, and asserting, verifying that your test is working as expected. So tests must have a clear and easily identifiable name. So for example, instead of expect null works, expects null returns true with null. This is so that if it fails, it's very easy to see in the logs why it failed. You want to avoid these big test functions that are filled with tons and tons of things testing one feature over and over again. You want to usually check one thing per test. This is really disputed. Some people believe you should only have one expect per test. Others believe it's reasonable to have more than one to avoid duplication of effort. For example, let's say you have an object and you're verifying that the initialization of that object is correct. And let's say it initializes like 5 variables. Some people would say you need to have a unit test for each of those variables. Other people would say you only really need to have one unit test to verify the initialization is correct. That's sort of an example of where it's disputed. So generally speaking, test one thing per test and keep it on topic. Otherwise, tests also need to be deterministic. They shouldn't fail randomly. They should be able to be run out of order. They should be able to be run over and over again. And each test needs to be self-contained. They need to handle setting themselves up and tearing themselves down and not influencing other tests. But, with all that said, when you talk about, unit testing and game development, the most common thing that I hear is, can't see myself using these, sorry. And a lot of people say, well, when would I even use this, right? Logically, you know that unit testing and automated testing will help with verifying your game works, verifying ports, doing performance tests, stress testing player input, simulating, economy, and assisting with game engine upgrades. But realistically, what you're asking when you have these problems is questions more like, is my world generation working as expected? Do people gain experience too quickly? Does it actually work, right? These are the questions that you're usually asking yourself when you're not sure if your features you've added are correct. And that's when, a unit test will probably help, right? So I'm going to go through a couple common scenarios that I have used unit tests in Gatela for, and I'm going to show you some code. And I'm just going to talk about when unit testing really helped me out. So the first one is I used it. This was when I first set up unit testing, And I used it to verify the functionality of a couple utility functions that I was using everywhere. And it helped me save a lot of time with testing when you looked at how long it would take for this particular issue to occur. So I have this utility function that converts frames into an hour, minute, second string. And I thought that it was working fine. But it turns out that when it switched over to 10 hours, there was an issue with the hour string not being formatted properly. And I only found it out when I was writing unit tests because I only test Catala in small chunks of time. It usually like a couple minutes, and I don't usually save the file. And so none of my save files have actually gotten to 10 hours or more yet, which is why I only found this when writing unit tests. It would have taken over 10 hours of someone playing the game to run into this problem, but it took milliseconds for the test to find it. So just to talk about converting this function into a unit test briefly, the first step is usually to find the branches. So like where does the code branch? And that helps you find like the key areas you need to test. So for example, GameMaker is a loosely typed language. So we need to test, what if someone passes in a string into this function? What if someone passes in a null value or undefined or a list? How is it going to handle it, right? Will it crash or not? So that's the first thing we have to test. Then we need to test, like, what if we pass in negative numbers or positive numbers or 0, right? And then there's testing that each individual string it equates properly to less than, equal, and greater than 10. And, if you really wanted to, you could test that the floors are working correctly, but that's a bit overkill, even though it is kind of a branch. So generally speaking, you should also be reasonable what to test and look for where the potential failures are. So this is a couple simple tests that I have of that. So I'm testing the branches that we identified before. I'm using a fixture test, which I will get into later. Basically, it allows for common setup and teardown of a test. GameMaker has frames set by game speed. So what the fixture test is doing is setting the speed to 1 to make 1 frame equal 1 second in order to simplify unit tests, and then resetting it back after. And so as you can see here, I'm showing, that I'm testing invalid objects like instances of functions. I'm testing undefined strings, the 10 hour, 100 hours, all sorts of things. And so that's one example. This is a more complicated example where I use the unit tests to determine that my randomness calculations are working properly. So Catala has a 30% chance of escaping from battles at the very least. And the problem with these probability questions, does it actually happen 30% of the time, is that, if you were to flip a coin 2 times in a row, you're not, sometimes you'll get heads or tails both times, right? Even though it has a 50-50 chance. But if you throw that coin enough times, it will eventually be close to 50-50. So when you have to do these random values, you have to run the same sequence over and over and over again to be sure that with the same configuration, it happens 30% of the time. So for a manual tester, this is really hard because the whole system changes your party setup, your enemy statuses, the levels. It takes hours to record results and verify, and I have a seed that affects the random value. So when someone's running this test manually, it's not always on the same seed. And that's where a unit test is more effective, because this can be done in less than a second. So here I have another fixture test to set up the basic, the battle, and set up the party and the enemy in a very basic way. I set the seed of the game to I set the seed of the game to a static value, so that every time when this test goes to run, it's always on the same seed. And I have the escape, the code that determines whether the escape happens or not, run 1,000 times, and then I expect that roughly 30% of the time it's going to happen. And this function in particular was it was useful for me to determine that this was working as it should have. But also, I just recently updated Gatela to the most recent version of GameMaker. They had made a change to how random numbers are calculated, and so this was actually failing. And because I had this test, I could go into that escape function, modify the value to what I needed it to be, and then the unit tests were passing again. So I'm going to talk about writing your own testing framework. And for starters, why should you even make a unit testing framework? And there's plenty of reasons why you shouldn't, but really each one depends on your situation and your own goals. So instead, let's talk about common reasons why you would want to. And the first one is, it doesn't exist. The reason I wrote a unit testing framework for GameMaker, it doesn't come with one, right? There's no options. So that's one. Another one, maybe there are options available, but they're all unusable. And unusable is a bit subjective. For example, maybe the maintainer hasn't updated it and it's not compatible with your version anymore. Maybe there's a lot of bug reports against it. Maybe it doesn't have the features you need, or it goes against your coding standards. There's a lot of reasons why you would determine something's unusable, but that's another reason. Maybe you can't extend it to do what you want, right? Or you just want to, right? You can do what you want. So when you're going to make a unit testing framework, you really need to define your key features. So I've primarily looked at JavaScript-based frameworks, so like Mocha and Jest. And so most of what I'm going to be going through is similar to that stuff, but it should be able to be applicable to other languages. Fundamentally, you need to be able to register, execute, report the status of a test, and show it to a user. And, there's a lot of different types of tests and different features. And, for example, synchronous tests, asynchronous tests, you should just define what type of tests you're going to support up front, because it will severely affect how you go about implementing your framework. And, the 4 basic test types are basic tests, fixture tests, parameterized tests, and parameterized fixture tests. And, when you're in doubt about what you should pick for your key features, just take a look at what other frameworks have and pick the lowest common denominator. And so going forward, I'm going to talk about how my GameMaker testing framework is set up, but the code is open source and available online. So if you're ever interested, you can just go look at it, really. So we're going to start with test registration. And to register tests, you need to have a manager. And this manager needs to handle the registration, the execution, and tracking the test status. And so adding a test to the manager is pretty straightforward. It's just adding the structure that has the test data to a list, and that's it. As for defining the test data, you have to decide on this very early about how you're going to do it. In this case, I have a struct and a basic test. As I showed earlier on, it has a name, it has a function, and in this case, it also has if it's disabled or not. A fixture test, which shares setup and teardown, needs to have a harness, which is just like a class. And a parameterized test will need to have an array of values to pass to the test function. I'm going to go in a little bit more detail about that later on. But as you can see here with the code, I define the default values and a helper to get the name for printing it out for the log. So finally, for the test registration, you need to define your API. And defining the API, especially your basic API, very important because you don't want to change this after the fact. If you can imagine, you've written 800 tests, you're now adding a new feature, you're changing the API. You have to update that everywhere. And if you have other people using your test, they're probably not going to be very happy. So create your basic API and make sure all your test functions call it. In this case, when you first define a test, it checks if there's a manager. If there isn't, it creates one. It then creates the test structure, assigns the information, adds the test, returns the structure. And then for the disabled version, it's marking it as disabled. And I'm going to go quickly over how execution works. And for the main body of it, you have your list of tests, and the manager is basically going to loop over your list, skip everything that's disabled, make sure that it logs what the status is and how much time it spent running the tests and how many were passed, failed, or skipped. That's basically what a manager does. When it comes to actually executing the given test, for a basic test, it really just needs to log when it's begun. It needs to run the test function, make sure to catch any exception that happens, and make sure it doesn't crash, and log if it's passed or failed. For the GameMaker testing library, we had to make our own assertion library. So in this case, it will throw an exception if it fails. That doesn't necessarily happen for every single framework, but that's how I decided this will work. So speaking of assertions, these are your expects. So for the GameMaker testing library, I had to make its own assertion library because there wasn't one. And what I do is it throws if the values don't match, and with what it expected, what it actually is, and what the stack trace is. And you know, each library you make and each framework is going to behave differently. So you know, factor that into how you do your test execution. But if you have to make your own assertion library, you need sort of like equals, not equals, null, not null, true, false, greater than, less than. And those are your basic assertions. So now on to fixture tests. And fixture tests are useful because it helps reduce your code duplication. It allows for a common setup and teardown of tests. And here's an example of that, our minute string fixture test from before. I use it to set the room speed to 1 to make the calculations for the test easier, and I reset it afterwards. And so this is how it works. It's very similar to your basic execution. You instantiate a new instance of the harness. You move the test function into the scope of the harness so that it has access to all the variables that are defined in the harness. And you do the same try catch as before, and with the setup and teardown. Parameterized tests, on the other hand, allow for reusing the same test function, and they can use a fixture or not. but each value in the array of values that you pass to a parameterized test will be sent to your test function. And so in this example, you can see here, instead of having 7 tests with almost exactly the same code, we have 1 test with the values and results swapped out. And parameterized tests are very similar to fixture tests as well. You loop through each element in the array and test it with the test function. But you also need to make sure that the test name includes which parameter is being executed, because they're executed in order. For simplicity, the GameMaker testing framework requires a harness for parameterized tests, but you don't need one. Part of that reason is also because GameMaker doesn't allow for 2 functions to have the same name. So it makes more sense to include a fixture when you're setting up your parameterized tests. And because there's a default harness included with it, you can just pass that in instead, and that way you can have a no harness parameterized test. So I just want to quickly go over supporting asynchronous tests, because it's actually quite complicated to add them. So the GameMaker testing framework is synchronous only because GameMaker doesn't support async very well. There's no such thing as promises or callbacks. So, you can't really use timeouts very well like that. And when you have lambdas, the functions don't get copied into them. There's a lot of restrictions in the language, and it'll probably improve over time, but for now, it's not supported. And the key thing is that with asynchronous testing, you need to factor this in at the very beginning, because it will affect your API, especially if you don't have things like awaits and promises and stuff like JavaScript does. So you may have to pass in another variable to say stop waiting or continue waiting or something. But when you have an asynchronous test, you need to make sure your manager will include a timeout. And a good timeout length is about 5 seconds. That's used by Jest and I believe Mocha as well. But that timeout is used to fail tests that take too long. You don't want your unit tests to hang when they're running because you're waiting from a response from a server or something like that and it's taking too long, or something like that. So the manager should be in charge of failing it if it takes too long. And yeah, that's pretty much it. So some other cool features you might want to add to your framework is filtering. You want to run only tests that start with the word skill, for example, or you want to repeat all your tests 100 times, or run them all randomly, right? Maybe you want to save the output to a file of a specific type like XML, or maybe you want to integrate with other reporting tools like Allure. You should really look at other frameworks for what they support. That will help you if you want to add new features, but really it's up to what you want and what you need. And I guess if you're doing it for fun, go ham, right? So now you have your unit testing framework and you want to make it public. You want to share it with people. You should ask yourself, do you have time to maintain it? Do you have time to document and add examples? Do you have time to answer questions, or is there even any interest? Not a lot of people are super interested in unit testing. You shouldn't expect crazy interest like you would with like a Unity plugin or something. Like it's not that great, but even a little bit of interest is usually a good sign. And I recommend verifying through Twitter or Reddit or forums. That's what I did before I published this. So you've decided to go public with it. Make sure to pick a place to host it. So Bitbucket, GitHub, NPM, marketplaces, etc. Pick a place where your intended users are to find it. And if you make it open source, make sure to document everything. You would be surprised that you don't just need to document the API people will publicly use. You also need to document the private stuff, because people will try to use the private. It's open source. People will try to use it. And this will take a lot more time than you think. It took me longer to document and make examples for the unit testing framework than to write the actual framework. So make sure to also include installation instructions, samples. Some people request video tutorials. If that's your thing, go for it. And make sure you pick an appropriate license. Also make sure to credit yourself or anyone else who has helped you with it. It's important if someone needs help or if someone has significantly assisted. And make sure to include how to contribute. If you don't want anyone to contribute, then you should outline that. If you want people to contribute, tell them how to do it. Just make sure those guidelines are there. And so thank you for listening. I'm sure this has been a very testing topic for you all. Do you have any questions? Okay, so assuming a system is likely to change somewhat, how do you decide when to write a unit test for a particular set of functionality? Do you usually build the test when the pieces solidify or even before that? I usually write the unit tests before that. Yeah, it's like if you add a new feature or you're fixing bugs, I would recommend to write the unit tests then and there if you can. You never know when you'll put something down for an extended period of time and you'll solidify it in a year later or something. Or maybe it'll be a week. Like you don't know. And you don't know if like doing engine upgrades, right? You don't know if you'll upgrade tomorrow and then it breaks everything or, whatever. So the sooner is usually the better because trying to catch up for unit tests is very, I would say mentally draining. Even if you think you can power through and get a bunch done in like 2 weeks, they're usually not as great as just doing it at the time. What do you think are challenges specific to games regarding unit testing, like with a typical game loop? I think, so when you think of software development, it's usually much easier to think of things as individual pieces. Like that utility function. It's very easy to look at that and be like, yeah, that's pretty easy to test. But when you're thinking about your game, it feels like it's something more cohesive. It feels like something it needs to test completely together. So I understand the difficulty when it comes to figuring out how do you even test it if you want to, right? And I think, first of all, I think you need to start small, right? Utility functions, things you use in a lot of places, are usually your best bet for starting on this path. When you move up to answering those questions like, is my random function even working properly? Those are a bit closer to, I would say, integration tests or system testing. It requires a lot of setup, and so it's usually better to start small and build up, because you'll find that you'll run into issues when you're building up to that big system test to check that your economy is working well in your game, right? That, it turns out that I can't actually instantiate this without the whole game running, right? And so you'll refactor and fix that earlier on than just going ahead and starting immediately with that hard rock. But I think usually the biggest issue is just it's a mindset, and when you're approaching unit testing that makes it hard. It's wanting to start with the bigger rocks instead of the smaller ones. And I think another big thing is the game engines. If your language you're using or the game engine you're using doesn't support unit tests or doesn't support it very well, you can end up with feeling very defeated when you're trying to do it, where it feels like it's fighting against you. And sometimes, you have to step back and be like, is it me or is it the engine? But I think that, it's definitely possible. Even a little bit helps and goes a long way for sure. I'm not sure if that fully answers everything though. Okay, that's great. How do you manage testing parts of your code that require interfacing with external systems tool, database, platform, API assets, etc.? Thinking of graphics. So for graphics, when you're testing anything visual, that's really something that's better set for a manual tester. Those things change a lot, and if you try to do like screenshot testing or video testing with it, they're very flaky and it's very easy to fail. So you usually want to avoid things like that. Or, let's say you want to render a blue square in the top left corner, right? Can that, be tested by doing like bounding box testing or something? Like, you don't know for sure if it's blue or not until you actually look at it, but generally speaking, it's probably blue and it's probably up there. Like, that's a couple things you can do, but yeah, usually visual things, that's a manual tester. You usually don't want a unit test for that. For external systems or tools like databases and APIs and stuff, that would also be an integration test. That's something where you need to have the application running, and you can still, if your framework is good enough, which it usually is, you can make an integration test with a unit testing framework. That's what I'm doing for the GameMaker framework. I'm running Gatela with a different menu, and then it's just executing all the tests. But I've also used like Gtest, and just running the application on the platform that you needed it. So it is possible to do it, but you'd be looking at integration testing, more of an end-to-end, making sure that things work appropriately. Those are usually asynchronous tests that you're looking at. For your GameMaker framework, how did you approach running the tests on each of your target platforms? Did you automate the testing across multiple devices, or was it easy to run the tests manually on each target? So right now I'm mainly on PC only. But for running it on different platforms, because it's being run as part of your game, it can run on any platform that GameMaker supports. The only one that might have some difficulty is HTML, because it doesn't handle the anonymous functions that GameMaker added in 2.3 very well. But basically, how I have it set up for Gatela is when I start the game with a specific build target. So, for example, I have it called unit testing. It will compile the game, run it. It will automatically start all of the tests and then close the game when it's done and put it in a log for me. So, in that case, I would just have to build and deploy to every device I wanted. I know that, that's not possible for some people, but that's how I have it set up. So if you're interested in looking at the framework, I have a link right here, but also if you just go to my GitHub or search my name, generally speaking, you will find it. And it's all open source. And if you have GameMaker, you can just download it and use it, because it's also in the marketplace, so you can add it to your project that way as well. So I think that is everything. Thank you very much for listening.